Good morning, all of you. Last class, we are completed a liquid type dielectric material introduction and suspended particle theory also we are completed. So today we will discuss the remaining concept of liquid type dielectric materials, remaining theories. Okay. In previous lecture, so we have completed some suspended particle theory that this is the relation we are getting. So we got this type of relations. Okay. And suspended particle theory. According to the suspended particle theory, so we got this type of relation. So according to this theory, when electric field that is called breakdown strength is depending on impurities. Okay, if the number of impurities are increasing, that means the size of the impurities is increasing. Okay, the size of the impurities goes on increasing. The breakdown strength of the dielectric material goes on decreasing. So okay, according to the suspended particle theory, so this concept we are observed. Okay, merit on it. And then today we will discuss so next concept of liquid type dielectric materials. So cavitation and bubble theory. Cavitation and bubble theory. This is the one of the concept. Okay, the following process has been suggested to responsible for the formation of vapor clouds. The following process has been suggested to responsible for formation of vapor bubbles. Okay, so because of vapor bubbles, the dielectric strength of the dielectric material, liquid type dielectric material goes on decreasing. Okay, am I right or not? Because of impurities in the dielectric material, breakdown strength goes on decreasing. So that's why we have to concentrating on liquid type dielectric material to improve the dielectric strength. Okay, so before going to the concept, we have to must know the concept of dielectric material properties. We already completed. Before understanding of the dielectric material property, we are already completed some topics in previous lectures. So the following process has been suggested to responsible formation of vapor clouds. First one is gas packets at the surface of the electrodes. That means if the liquid type dielectric material is subjected to the high voltages, so what happens when the liquid type dielectric material is subjected to the high voltages? Because of that, the electrons are released from cathode. Okay, and current increasing, and also the loss is increasing between two electrodes. Because of that, temperature of the dielectric material goes on increasing. Once temperature increasing means the electrodes, the bubbles are formed on the surface of the electrodes. Okay, because of high voltage, very high temperature appear in between two electrodes. Okay, that's because of that the bubbles are formed on the surface of the electrodes. So next, electrostatic repulsive force between the space charges, which may be leads to sufficient to overcome the surface tension. When the surface tension of the liquid type dielectric material goes on decreasing, okay, the breakdown strength is also goes on decreasing. That is the problem we are observing. If electric repulsive force between the space charges are which may be lead to sufficient to overcome the surface tension. If the surface tension is decreasing, that means the dielectric strength of the breakdown strength of the dielectric material is goes on decreasing. Okay, so next, gaseous products due to the dissociation of liquids molecules by electron collisions. You know well, when if high voltage appear across the liquid type dielectric materials from cathode, so electrons are released. Initially, some electrons are released. That electrons are collided with liquid molecules. Okay, same as gas molecules. Here also liquid molecules, and they will become ions. Okay, the ions are attracted by the negative plate, and the electrons are attracted by the positive plate. In between these two, there is a collision, electron collision we have observed. Because of that, the avalanches. So according to the steamer theory, so we are observed different types of avalanches. So like that, the liquid type dielectric material breakdown strength of the liquid type material goes on decreasing. Okay, if the electrons, more number of electrons are increasing between two electrons, that means it instead of it acting as an insulator, it will act as a conductor. Okay, so next, vaporization of liquid corona-type discharge from sharp points and irregularity on the electrode surfaces. Because of that, also the liquid type dielectric material, dielectric strength of the material goes on decreasing. Okay, so because of this also the dielectric strength of the liquid type dielectric material goes on decreasing. So you know well, the corona is nothing but when high voltage, whenever the dielectric material is subjected to the high voltages, the surface of the conductor is appear as a faint violent glow like this manner. The violent glow is appear like this manner. Okay, and also there is some sound is producing that is called sing sound. Okay, that means when under high voltage condition, the surrounding air or liquid or solid or anything, it comes to ionizing. Okay, surrounding part of the insulating material is comes to ionizing, and then it will act as conductor. So because of that, dielectric strength of the liquid type dielectric material goes on decreasing. Okay, so then this is the one numerical formula. So here, according to the cavitation bubble theory, so E naught is equal to 1 by epsilon 1 minus epsilon 2 into 2 pi sigma into 2 epsilon 1 plus epsilon 2 by r. Then pi by 4 into r naught of pi by 2 r eta in not in minus 1 over the power 1. But this is some simple expression. So then the derivation of this is not required. Okay, so according to this uh, formula, we can say that how the dielectric strength of the liquid type dielectric material is goes on changing. So here sigma is called a surface tension of the liquid. That means the liquid type dielectric material dielectric strength is depending on a surface tension. Okay, epsilon 1 is permittivity of liquid and epsilon 2 the permittivity of the gas bubbles, and R is the initial radius of the bubble assumed as sphere, and V is called voltage of a bubble, voltage drop in the bubble. So this is the concept according to the bubble theory, cavitation and bubble theory. Okay. So these are the simplest way to explain the concept of dielectric material is called first one, gas packets in a liquid. Gas packets in a liquid. Second one, irregular surface of the operating electrode. Second one, this third one, change in temperature and pressure. Okay, change in hydrostatic pressure. Okay, these are the different types of conditions. The cavitation bubbles are theory concept coming to picture. Because of gas packets in electrodes, because of irregular surface on the operating of electrodes, change in temperature and pressure, change in hydrostatic. Because of these reasons, the bubbles are formed inside of the uh, liquid dielectric material, and also cavitations are observed and bubbles are formed inside of the liquid material. Because of this, the dielectric strength of the insulating material goes on decrease. Okay, it's clear. And the next concept, stress oil volume theory. According to the stress oil volume theory, the breakdown voltage is highly influenced by the gas content in the oil. The breakdown voltage is highly influenced by the gas content in the oil and viscosity of the oil and presence of other impurities. Because of impurities in liquid type dielectric material, the breakdown strength of the is decreasing. That means the breakdown voltage of the liquid type dielectric material is depending on oil viscosity, impurities. Okay, the more number of impurities are present and liquid type dielectric material, the breakdown strength of the insulator goes on decreasing. These being uniformly distributed, increases the stress oil volume, consequently results in reduction of the breakdown. Because of these impurities, there is a stress observed and between across the inside of the liquid type dielectric material. Because of impurities, the stress is increasing. Because of stress, there is a possibility of reduction in breakdown voltage. Okay, so this is the problem we are observed. According to the stress oil volume theory, the liquid type dielectric material subjected to the high stress, the breakdown voltage is decreasing because of impurities. Because of impurities, the dielectric strength of the liquid type dielectric material goes on decreasing. So according to the stress oil volume theory, we have to consider here the main concept of the stress oil volume theory is, according to the stress oil volume theory, the variation of breakdown voltage stress is stress oil volume theory. According to this, we can observe that the variation of the to constant here. According to this theory, breakdown strength is inversely proportional to the stressed oil volume. According to this theory, breakdown strength is inversely proportional to the stressed oil volume. If the oil stress is increasing, the breakdown strength is goes on decreasing. Okay, by using this concept, so we have to draw one graph. So according to the graph, we can understand the concept of liquid dielectric material. So here, the stressed oil volume goes on increasing like this manner. Stress of the oil goes on increasing like this manner. The breakdown of stress, that is called breakdown strength, is decreasing like this manner. Under less stressed oil, okay, under less stressed oil, that is called 10 to the power of minus 2, less stressed oil volume condition, the breakdown strength of the liquid dielectric material is high. Okay, when stress in the liquid dielectric material goes on increasing, so like this manner increasing, the breakdown strength is goes on decreasing. Okay, the breakdown strength of the liquid dielectric material goes on decreasing. So like that, according to the stress volume theory, we have observed dielectric strength of the liquid dielectric material. Then electronic breakdown. Coming to the electronic breakdown. So according to the electronic breakdown, once an electron is injected into the liquid. So how the electron is injected? When liquid dielectric material is subjected to the high voltages. So from cathode plate, electrons are released and the electrons are injected into the liquid dielectric material. Am I right? Once a liquid dielectric material is subjected to the high voltages, from cathode plate, some electrons are released and that electrons are injected to the liquid. Okay, so according to the electronic breakdown, so we are observed like that. It gains energy from electric field applied between the electrodes. Am I right? Okay, it presumed that some electrons will gain more energy due to field than they would lose during collision. All right. The electrons are released from cathode plate and these electrons are collide with liquid molecules. Okay. And then there is a collision. Because of collision, the more number of electrons are released. These electrons are accelerated under electric field and would gain sufficient energy to knock out an electron and then initiate the process of avalanche. Okay, so like that we are observing. That means if liquid dielectric material subjected to high voltages, from cathode plate there is some electrons are released. The electrons are collide with gas molecule, liquid molecules. Because of that, the more number of electrons are released from liquid, and also positive ions or negative electrons are formed. Because of that, there is a possibility of increasing the avalanche. Because of that, there is a breakdown of insulator we are observing. Okay, so this is the concept according to the under threshold condition. Under threshold condition, this is the equations we are observed. Okay, during ionization process, this is the observed threshold condition under the condition. E is called electron charge, lambda is called a mean free path, and is called external energy. This is called constant. HV is called energy gain, energy of ionization. HV is the energy of ionization. So like that we are getting. Okay. So a simple way to understand the electron breakdown is this is called two electrodes in between a liquid dielectric material is subjected to high voltages. Electrons are released from cathode plate and they collide with electrons are released and they collide with liquid molecules, and because of that avalanche is formed and the medium get conductive. So like this manner the electron breakdown. The threshold condition E lambda E is equal to CHB. E is called 1.6 into 10 to the power minus 19 coulombs in novel. Lambda is called wavelength. Okay, E is called electric field, external electric field, and H is called Planck's constant. 6.63 into 10 to the power minus 34 joule seconds, and V is called frequency. So according to the electron breakdown, so we are observed like this manner. Next, steps for formation of electroconvention breakdown. These are the different types of steps we are observed between two dielectric materials, between two electrodes plus the dielectric material, liquid type dielectric material. This is the process we are observed. First, we are applying high voltage. So under high voltage condition, the electrons are ejected towards the liquid. From cathode, the electrons are released and they is injected into the liquid type dielectric material. Because of that, positive ions and the negative electrons are formed like that. You know well, according to the streamer theory, the avalanche, how the avalanches are formed. The avalanches take place. Okay, because of the different types of avalanches are in liquid, there is a space charges are we are observed. Space charges we are observed. Because of space charges, there is a coulombic force in between these two space charges. Because of that, the electric field will come non-uniform, and there is a hydrodynamic instability observed in the liquid types dielectric material. Hydrodynamic instability, and then formation of convention current, that is called eddy current. Instead of liquid, instead of acting as a insulator, it will be acting as a conductor. So that's why the liquid type dielectric material lost its property. So it will acting as a conductor. So that is the problem we are facing when impurities are placing in inside of the liquid type dielectric material. So next, last concept, power law. Next, what is in by power law? Okay. The power law is also called as scaling law. State that relative change in one quantity results in a proportional relative change in another quantity. So according to our high voltage engineering point of view, so change in one quantity, the relative change in another quantity is nothing but change in one quantity is nothing but a distance here. Change in one quantity is called a distance. If distance is changing, the breakdown voltage of the insulator goes on changing. Okay. So according to the power law, we are getting this is the relation. Okay. By using power law, we are getting this type of relations. So VB is equal to K into D power N. So that's here K and N are variables, and VB is called breakdown voltage, and D is called distance. So like that, the power law we are observed. Okay, so next, based on power law, so we have to observe some numerical problems regarding to the power law. This is one numerical problem. The following observations made in an experiment for determination of dielectric strength of the transformer determine power law equations. So this is called gas spacing in centimeters, and breakdown voltage. So like this, for 4 centimeter 88 kilovolts, for 6 centimeter 135 kilovolts, 8 centimeter 165 kilovolts, 10 centimeter 212 kilovolts. So like that, we are observing the one problem. So let us assume, according to this problem, let us assume we know well, according to the power law, there is a relation VB is equal to K into D power N. So by using power law, so we are taking one distance at 4 centimeters, we are taking breakdown voltage 88 K. So VB is called breakdown voltage. 88 is equal to K into D power N. So D is called 4 centimeter. And then I'm taking another gas spacing, that is called 8 centimeter. So 165 is equal to K into D power N. So like that, by dividing these two, so 165 by 88, 8 power N by 4 power N, that is will become 2 power N. So apply on ln on both sides, we are getting, so N is equal to 0.9068. And then substituting K in this equation, I mean N in this equation or in this equation, you will get K. Okay, similarly, by taking second and fourth observations, I'm taking first and third. So second and fourth observation also, we are by taking that, so we are getting N value and K value. By taking that, therefore the average value of N is equal to average, by taking the average of these two. Okay, first, second and fourth observation and first and third observation, so we are getting and K and N. By substituting K and N, we are getting the equation like this. Okay, so one is assignment for you. And an experiment for determining the breakdown strength of transformer, the following observations were made. Determine the power law depends upon dependence between the gas spacing and the applied voltage. Okay, gas spacing is mm, 4 centimeter, 6, 4 millimeter, 6 millimeter, 10, 12 like that. Breakdown strength 90, 140, 210. So same as a previous problem, the same procedure, and find that power law, find by using this data, find power law. So that by taking first and third observations, and by taking second and fourth observations, the average of two observations, find the N, and the N will become 0.947, and similarly K value also. So then finally we are getting relation VB is equal to 24.5 into D power 0.957. So okay, this is about today's lecture. So next class we will discuss solid type dielectric.